understanding how the graphs of parabolas are related to their quadratic functions. The general form of a quadratic function presents the function in the form of f of x, which is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. Now, if the value of a, being the leading coefficient, is positive, meaning that it's greater than 0, the parabola opens upward. If a is negative, meaning it's less than 0, then the parabola opens downward. We can use the general form of a parabola to find the equation for the axis of symmetry. The axis of symmetry is defined by x, which is equal to negative b over 2a. If we use the quadratic formula to solve ax squared plus bx plus c equals 0 for the x-intercepts, or zeros, we find the value of x halfway between them is always x is equal to negative b over 2a, the equation for the axis of symmetry. Now, figure 4 represents the graph of the quadratic function written in general form as y equals x squared plus 4x plus 3. In this form, we can see that the a value is 1 and it's positive. We can see the value of b is 4, and we can see that the value of c is 3. Now, because the value of a is greater than 0, then the parabola opens upward. The axis of symmetry is x, which is equal to negative b over 2a. Well, that gives us negative 2. So that tells us where the axis of symmetry is. This also makes sense because we can see from the graph that the vertical line is at x equals negative 2 is the axis of symmetry, and it divides the graph in half. Now, the vertex always occurs along the axis of symmetry. For a parabola that opens upward, the vertex occurs at the lowest point on the graph, and in this instance, negative 2, negative 1. Now, the x-intercepts, where it crosses the x-axis, those points where the parabola crosses the x-axis, occur at negative 3, 0, and negative 1, 0. Now, the standard form of a quadratic function presents the function in the following form: f of x, which is equal to a times x minus h squared plus k, where hk is the vertex. Because the vertex appears in the standard form of the quadratic function, this form is also known as the vertex form of a quadratic function. As with the general form, if a is greater than 0, or if a is positive, the parabola opens upward and the vertex is a minimum. If a is less than 0, meaning if a is negative, then the parabola opens downward and the vertex is a maximum. Now, if we take a look at figure 5, it represents the graph of a quadratic function written in standard form as y is equal to negative 3 times x plus 2 squared plus 4. Now, since x minus h in the parentheses is equal to x plus 2, in this example, that means that h must be negative 2. In this form, a is negative 3, h is negative 2, and k is positive 4. So, because a is less than 0, meaning that it's negative, we know that the parabola opens downward. We can determine that the vertex is at hk, which is negative 2 and 4. And so we can see that in figure 5, this is representing the graph of a quadratic function that is written in standard form. Now, the standard form is useful for determining how the graph is transformed from the graph of y equals x squared. Figure 6 is the graph of this basic function. Now, if the value of k is greater than 0, the graph shifts upward, whereas if k is less than 0, then the graph shifts downward. In figure 5, k was greater than 0, so the graph is shifted 4 units upward. Now, if h is greater than 0, the graph is going to shift towards the right. And if h is less than 0, then the graph is going to shift to the left. And in figure 5, h was less than 0, so the graph is shifted 2 units to the left. Now, the magnitude of a indicates the stretch of the graph. So if the absolute value of a is greater than 1, then the point associated with a particular x value shifts farther from the x-axis. so the graph appears to become narrower and there is a vertical stretch. But if the absolute value of a is less than 1, the point associated with a particular x value shifts closer to the x-axis, so the graph appears to become wider. But in fact, there is a vertical compression. So in figure 5, the absolute value of a is greater than 1, so the graph becomes narrower. Now the standard form and the general form are equivalent methods of describing the same function. We can see this by expanding out the general form and setting it equal to the standard form. So here is the standard form, and here's the general form. So we can expand this by the following. If we take x minus h squared and multiply it, we get ax squared minus 2ah plus ah squared plus k. And that's equal to a squared plus bx plus c. Now, for the linear terms to be equal, the coefficients must be equal. So we can say that negative 2ah is equal to the value of b over here. So what it's saying here is that this has a variable x and that has a variable x. And so we can set the coefficients negative 2ah equal to b. And then if we solve for h, we can divide both sides by negative 2a. And what that does is that gives us the axis of symmetry as we defined earlier. Now, if we set the constant terms equal, so what are the constant terms? Well, the constant terms are a h squared plus k, and we're going to set that equal to c. And now we're going to solve for k. Solving for k, we have to subtract a h squared to both sides, and then we're going to plug in a or h in for what we have here for h. So c minus a times b over 2a squared. So if we square this, we get b squared over 4a squared, and we can simplify one of the a's. So we get c minus b squared over 4a. So in practice, though, it is usually easier to remember that k is the output value of the function when the input is h. So f of h is equal to k.